Okay, so after a while, I finally finished designing the PCBs for this planar transformer design. Um, so here are the PCBs. As you can see, here are the windings. These two PCBs are for the primary winding design. Um, as you can see, here is the design that I shown in my videos. Specifically, this PCB, I believe, is it's this one. As you can see here, this is the same PCB as this one, and this other one, which is this is this one. This is upside down. And here's I have the two PCBs soldered together. Here they stack. As you can see, these two PCBs are for the primary winding of the transformer that I've shown in my previous videos. And here's the two cores that make the core for the transformer design. As you can see, here's the gap, and this is the core that I used for the simulations here. This is the full design of the transformer with the PCBs assembled. So, as you know, I made some simulations to measure the inductance and other, to calculate the inductance and other parameters for the transformer design. So let's test what's the result realistically for these two PCBs that I've made. Let me pull the LCR and do the measurement to see if the simulation was actually correct. As you can see, I have them in microhenries. Let me pull the probes and measure the inductance. As you can see, it gives the result of 183.84 microhenries. So let's check the inductance, the simulation inductance. I have it in one of my videos, but let me see if I can pull the simulation here. I believe it's this one. Let's see if I have the results. No, this does not have the results. Is this one? I believe it's gonna be this one. No. This one? No. Well, you can find it in my videos, but I'm struggling to find the model that I use for the simulation. I believe this is for the secondary winding. Yeah, this is for the secondary winding. Let me see if I can find the primary winding. I believe this is the one for the primary winding. Yes, this is the primary winding. As you can see, the inductance in microhenries gives a result of 172 microhenries. So yeah, as you can see, the simulation was pretty spot on. We did the correct setup and it worked. As you can see, the result is very close to what we measured in our real design test. 183.84. It's close enough. It's as close as we can get with the simulation. So as you can see, here's the design of the primary winding of the power supply I am designing. So let me pull. I also designed the PCB for the power supply. As you can see, this is the power supply, the PCB for the power supply. As you can see, this is the secondary winding. This is in the main PCB board for the power supply. There is not the chip is not soldered, but the rest of the components are soldered already. And as you can see, if I can zoom in, if I can focus this is the auxiliary winding for the flyback power supply. I cannot see it, but if I open the PCB design in Altium, you can see this is the secondary winding. These are in all 4 layers, and in the bottom layer I have this auxiliary winding. As you can see, the lines are much more thinner because they don't carry much current. This is basically only to measure the output of the power supply. But let's measure the inductance of the secondary winding. Pull the LCR. The port for the power it's over here. Let's see if I can measure over here. As you can see, without the core, I believe there's an issue with this. I will need to measure from the bottom. It doesn't work from the bottom. It doesn't give me any measurement because I don't have the core on this PCB. Or maybe I'm not just touching the pads. Oh yeah, I had an issue with this PCB. Let me pull another PCB because there was a manufacturing mistake because these vias are not plated inside, so they're not making contact. So I had to do some little fix. This other PCB, but I did the fix. As you can see, I already have the other PCB soldered. This is just a prototype. So let me measure this without the cord to see how much I get. I get basically nothing. So let me try putting the ferrite cord to see if I get some measurement. Okay, now let's see. I still get nothing. So weird. Okay, I find the issue. It's not making contact with the with the windings on the secondary. So I must measure from here to here. So as you can see, it gives something like about 17 microhenries. So what it gives. So let's check the simulation to see how much it will solve. I believe the secondary simulation is this. As you can see, this is the PCB for the secondary winding. The same one we got here. So let's check the results. And as you can see, it's 14.5. It's very close. We got in the physical design 17. So yeah, it's also correct, the simulation. The simulation was spot on here. So yeah, this is the results of the final design. And yeah, in the future I'm going to try to test this PCB because it has some issues. But yeah, I didn't measure the auxiliary winding yet, but it should be correct as well. So yeah, that's it. I just wanted to show you that the simulation actually works. And it's according to the physical design. It's really nice.